Welcome, my dear learners, to today's episode on this very channel. In today's lesson, we shall be looking at exponential equation, which is also known as indical equation. When we talk about exponential equation, we are referring to an equation which involves powers of numbers. In other words, when you have an exponential expression which involves the equal sign, then you can say that equation is an exponential equation. Examples of exponential equation is what I've written on the board. So you can see that we have an exponential expression and then we have the equal sign. So this equation becomes an exponential equation. The same thing applies to this and then that. So all these and many more are classical examples of exponential equation. How do we solve questions on exponential equation? To solve questions on exponential equation, what we have to do is to express each number on either side of the equal sign as an exponent of the same base. And once the bases are equal, we pick their exponents and then we equate them. Now what I mean is this. When you have, let's say, a raised to the power x is equal to a raised to the power 2. Now on either side of the equal sign, we have a base of a base of a. The bases are equal, and once the bases are equal, we pick their exponents and then we equate them. Another example is when you have, let's say, x raised to the power, let's say, 3x is equal to x raised to the power 6. Now you can observe that on the left hand side of the equal sign, we have a base of x, and then on the right hand side of the equal sign, we have a base of x. And since the bases are equal, we just equate their exponents. So we have 3x is equal to 6. This is how we solve questions on exponential equation. Now under the topic exponential equation, we are going to look at exponential equation that leads to linear equation, exponential equation that leads to a quadratic equation, and exponential equation that leads to a simultaneous equation. So we are going to look at this one after the other. But first on the list, we are going to look at exponential equation that leads to linear equation. So let's go through these examples and then see how best we can solve them. So we have our first question. We have to solve this exponential equation. In other words, we have to find the value for x. So as I intimated earlier on, to solve questions on exponential equation, what we have to do is to express each number on either side of the equation as an exponent of the same base. So on the left hand side, we have a base of 2. But on the right hand side, we have a base of what? 8. So we have to express this in an index form with a base of what? 2, so that we can equate their exponents. We know that is the same as what? 2 times 2 times 2. And we can write this in an index form as what? 2 raised to the power 3. So in place of 8, we are going to substitute 2 raised to the power 3. So we have 2 raised to the power x is equal to 2 raised to the power 3. Since the bases are the same, what we have to do is to just equate their exponents. So from here, you can say that our x is equal to 3. Very, very, very easy. You can cross check it. We have our x is 3, so 2 raised to the power 3 is 8, and 8 is equal to 8. Very, very easy and then simple. Let's look at our next example. So we have our second example, we have to find the value for this in this exponential equation. So realize that on the right hand side, we have a base of 5, but on the left hand side, we have a base of what? 25. Therefore, we have to express 25 in an index form with a base of what? 5. So we know that 5 times 5 gives us what? 25. We can express 5 times 5 in an index form as what? 5 raised to the power 2. So in place of 25, we are going to substitute 5 raised to the power 2. So we have 5 raised to the power 2, but we have x minus 1, and this is equal to 5 raised to the power x plus what? 2. Now, since the bases are the same, what we have to do is to just equate their exponents. So we are going to have 2x minus 1 is equal to x plus what? 2. Let's expand this bracket. We have 2x minus what? 2, and this is equal to x plus what? 2. Now let's do some transposition. Let's transpose the whole of negative to the left hand side of the equation. So we are going to have 2 plus 2 plus x, and then let's bring this x to the left hand side of the equation so that we have 2x minus x is equal to what? 4. This will give us x, and this is what? 4. So therefore, the value for this, or the value for x which satisfies this equation is 4. Very, very easy. Let's look at our third example. So we have to solve 7 raised to the power x plus 3 is equal to 1 over 49. Now remember that when you have 1 over a, it can be written as what? A raised to the power negative 1. That is the negative index property from this particular property. So it means that we can write this as that. So we are going to express this in the form of what? This property. So we have 7x plus 3 is equal to, we have 49 raised to the power negative 1. Now I want the bases to be equal so that we can equate their exponent to find the value for x. So we know that 7 times 7 gives us what? 49. And we can write 7 times 7 as what? 7 raised to the power 2. So in place of 49, we are going to substitute 7 raised to the power 2. So we have 7x plus 3 is equal to 7 raised to the power 2, and then we have multiplying negative 1. Since the bases are the same, we just have to equate their exponents. Negative 2. So we are looking for what? X. So we have our x equal to minus 3 minus 2. So therefore our s is equal to minus 5. Very, very easy and then simple. Let's look at our next set of questions. So we have our next set of questions. We have to find the value for x in each of these exponential equations. So let's start with this particular one. So from this, we know that when you have, let's say 1 over a, it can be written as what? A raised to the power negative 1. That is the negative index property from this side. So when you have 1 over a, we can write it as this. So it means that with this aspect, we can rewrite it as this. So we are going to have 125 raised to the power negative 1 all raised to the power x, and then minus. We can also write this in this very form. So we have 25 raised to the power negative 1 all raised to the power 3 over 4, and that gives us what? 0. Applying the power law, we shall have 125 minus x and then we have 25 minus 3 all over 4. Now let's bring the whole of the 25. So we have 125 raised to the power negative x is equal to 25 raised to the power negative 3 all over 4. Now I want the base on either side of the equal sign to be the same. And we know that 25 can be written as 5 times 5. And writing this in an index form with a base of 5, we are going to have 5 raised to the power 2. And 125 can be written as what? 5 raised to the power 3. So in place of 125, we are going to substitute this, and in place of 25, we are going to substitute this, so that the base will be equal, and then we equate their exponent. Now applying the power law, we can write this as 5 raised to the power negative 3x, and then we can also write this as 5 raised to the power negative 6 all over 4. Now we can see that the bases are equal, and therefore we can pick their exponent and then we equate them. So we have negative 3x is equal to negative 6 all over 4. Negative will cancel negative. We are looking for x, not 3x. So we divide both sides by 3. So we have divide here by 3. And then when we divide here, we can turn it to be a multiplication like this. So this will cancel this. And then we have this 3 will cancel 6. We have 2. So we have 2 over 4. We can still further break it down as this into that. We have our x is equal to 1 over 2. Very, very easy. Now let's look at our next example. We have to find the value for x in this exponential equation. Now we know that from this property, when you have root of a, you can write it as what? A raised to the power half. So when you have root of 2, you can write it as what? 2 raised to the power half. So in place of these 2 here, we are going to write 2 raised to the power half. So we have 8 raised to the power 3x is equal to 2 raised to the power half. Now we want the bases on either side of the equal sign to be the same. So let's express 8 in an index form with a base of what? 2. So you know that we can write 8 as 2 raised to the power 3. So in place of 8, we are going to substitute 2 raised to the power 3. So we have 2 raised to the power 3, and then we have our 3x is equal to 2 raised to the power half. From here, applying the power law, we'll be having 2 raised to the power 3 times 3 will give us 9x raised to the power 2 raised to the power half. Now, since the bases on the left hand side and then the right hand side are equal, we are just going to equate their exponents. So we have 9x is equal to 1 over 2. We are looking for x, not 9x. So we divide both sides by 9, divide both sides by 9. This and that will go. We have our x is equal to 1 over 18. As easy as that. Let's look at our last but not the least. We have to find the value for x in this exponential equation. In other words, we have to solve this equation. Now we know that 2 can be written as what? 2 raised to the power half. Now we have a base of 2, a base of 2. Why don't we express 1 to 8 as an exponent with a base of 2? So we know that 128 can be written as 2 raised to the power 7. So in place of 128, we are going to substitute 2 raised to the power 7. So we have now multiplying 2 raised to the power half. Now you know that this is 2 raised to the power 3x minus 1. Now applying the multiplication law, when two numbers are multiplying, they have the same base. We pick one of the base we add their exponent 7 plus 1 over 2. So we have 2 raised to the power 3x minus 1 is equal to 2 raised to the power, this will give us 15 all over 2. Now once the bases are equal, we just equate their exponents. So we have 3x minus 1 is equal to 15 all over 2. Now doing your cross multiplication, we are going to have 2 multiplying 3x minus 1 is equal to 15. Expanding the bracket, we have 6x minus 2 is equal to 15. Let's transpose the whole of the negative 2 to the right hand side of the equal sign. So we have 6x is equal to 17. We are looking for what? We are looking for x. So we divide both sides by 6, both sides by 6. This and that will go. We have our x to be equal to what? 17 all over 6. As easy as A, B, C, D. Let's look at our last example. Now we have 3 raised to the power x, and then we have 8. Now we want the base on either side of the equal sign to be the same. But realize that we can't express 8 in an index form with a base of 3. It is not possible. So how are we going to solve questions of this nature? To solve questions of this nature, then we are going to introduce what we call logarithm to the base of 10 on either side of the equal sign. So we have log 3 raised to the power x to the base of 10. Then we have log 8 to the base of 10. Now from here, we are going to apply one of the laws of logarithm. When you have log b raised to the power x to the base of a, it can be expressed as what? X log of b to the base of a. So we have our x will come in front. We have log 3 to the base of what? 10. And then we have log 8 to the base of what? 10. Now from here, we can divide both sides by log 3 to the base of 10. Divide both sides by log 3 to the base of what? 10. So that this will cancel this. We have our x is equal to log 8 to the base of 10 divided by log 3 to the base of 10. Now when you point this on your calculator, we are going to have our x to be 1.8927. So x is equal to 1.8927, and that is the value for x. This brings us to the end of today's lesson. So see you tomorrow. Bye bye.